So we're doing 9.1 number 2. Now, with number 1, we took a Fahrenheit number and turned it into a Celsius number. That way, if your friend is from anywhere on the planet Earth, aside from the United States, they will understand what your temperature is. But what if your friend is not from somewhere else on planet Earth? What if your friend is in fact a Martian? What if they're from another planet? Well, we have a system for that. We have a system that's called Kelvin. And Kelvin is a system, well, let's just say it's a very logical system for working on things like the temperature of stars, the temperature of nebulas and asteroids, and things out in space where our current system of Celsius doesn't work so well. Our system of Celsius really works well for a world that is covered with water. 0 is the freezing point of water, 100 is the boiling point of water. For a water planet like Earth, which is mostly covered with water, it's a great system. But if you're from a different planet, it doesn't actually make a lot of sense to peg everything to water. So what we are doing is we're going to convert it to degrees Kelvin. Now this, for all its talk about our space, is actually about one of the simplest things you can imagine doing. To get to the temperature Kelvin, you simply take the temperature Celsius and add 273.15 degrees. Now the reason for this is the Celsius scale zeros at the freezing point of water. The freezing point of water is 273.15 degrees above absolute zero. So if we want to find the temperature Celsius, we just simply take that and add that. Now I have 22.7, so we're not going to do it quite that crazy. TK is equal to, let's say, 23 degrees plus 273.15, blah, 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 blah. So, add them to get, I'm sorry, that's a K, sorry about that. So temperature Kelvin is going to be equal to 296.15 degrees. Now, word around here. The 0.15 is important if you're working with numbers that are that precise, but this is only precise to the ones place. We can't really say this. And in fact, if you look back, we really had rounded it there. If you added 0.15, you end up with actually, if you put in what we really had gotten, you would actually have something a little less than 296. But in both cases, you're rounding to 296. So your answer is temperature Kelvin is equal to 296 degrees. So the temperature in El Monte right now is 296 degrees above absolute zero. Now, number sense. With an equation like this, there are very few ways to screw it up. The only way you can screw it up is if you put your temperature Celsius where the temperature Kelvin goes, and then solved for the other thing. If you did that, you would get a negative number. Now, absolute zero is the absolute coldest you can get. There is nothing below absolute zero. You will never, ever, ever get a temperature in Kelvin that's negative. So if you mess it up and you get a negative number, then you know you've done something wrong. And the problem probably is you put this there and that there. That's probably what you've done. Highly unlikely to happen. It's a fairly simple equation. And by the way, numbers, almost everything on Earth is going to be somewhere in the 300 range Kelvin. If you go to other planets, if your friend from Mars, he's probably maybe, has days down at around 200. But that's on Mars, and I've never been there. I will talk to you later. Bye-bye now.